computer, please. All right, so your data sets for the application, oops, wrong button, get my shit together soon. There we go. Is right here. So I present it as a Google Sheet. The description of this one says to use for each state and Washington, D.C., so that's the 51, the percentage of people without health insurance in 2016. So in that opening line, I'm basically saying use column B here. I included the margin of error there just for fun because, go away Google, stop bugging me. We're going to cover margins of error later in the course. And what does a margin of error mean? So let's pick Oregon, for example, and some of you heard me talk about this before. The claim is that 6.2% of Oregonians in 2016 were without health insurance. How do they know that? They didn't ask me. Maybe they asked my employer. They did a random sampling of some sort. Now, since it's a sample and not everybody, they don't know for sure it's 6.2. So there's a way to calculate how far off you might be. The margin of error says they're within 0.2 of the actual number most of the time. So that means if I take away 0.2 from 6.2, there's a low of possibly 6% of people. Oh, this is in view mode. Another important thing, for those of you who are Google users, make sure you sign in and then make a copy of this for you to work with. If you're not a Google user, then you will need to download it as an Excel file, and then you can work with it from there. So anyway, the 6.2 is a guess, and they think it's actually somewhere between 6% and 6.4%, so plus or minus the 0.2. So you don't need to use the margin of error. You don't need to use the 2019 through 2014 data. You just need to use 2016, the percentages. And you're going to make a table that has frequency, relative frequency, and based on those, you'll create a histogram for frequency, a histogram for relative frequency, and then add a box plot to it. And I sent out a video. It's in the announcements about how to take a box plot from some box plot generator and get it into a spreadsheet. So please check out that video if you haven't already. All right, so let's see, I'm answering the first question. I answered the third. I'll get back to the second question from Charlotte in a moment. So here is my random sample in sheet 2. I should label that random sample size 50 of some of the countries. So I want to, again, I can't just look at those numbers and say, yeah, I get what those numbers are telling me. I have no idea. I mean, that's a mess of numbers. I don't know what it means. So we got to make some charts and graphs. When we do that, it's not clear how we should organize the groups. And so you have to play around to do that. One quick way to play around is to highlight the data. And I'll delete this chart after, but this is just a way for me to kind of get warmed up and ask Google to make a histogram for you. So somewhere down here, Google has a quick histogram builder. The problem with this is it skips over making a frequency table, which I want from you. So here Google said, hey, you know, with this data set, I think 1, 2, 3, 4, 5, 6, 7 columns looks good. And they range from what, 5 to 11.43. So those are kind of weird splits. So it looks like they're jumping by about, well, a little over 6 each time. So that just gives me an idea. If I wanted 7 groups, then I should have a width of about 6 or 7. And that these aren't percents, again, they're birth rates. So let's delete that. Gives me an idea. Come on, go away chart. There you go. So usually I do a little summary statistic off to the side here. I want to know what's the minimum number in the list, what's the maximum number in the list. That'll give me a range, max minus min, and that'll help me figure out the width of each bin. So I also want to know the number of bins, and I also want to know the bin width. And I have to calculate those somehow or guess at them. And you could just make a random guess. You could say, hey, I'm just going to start at the min and jump by 5. That's cool. If you think it looks good, go for it. So equals min, highlight the data, close your parentheses, highlight the max, or find the max, excuse me, highlight the data. All right, so we have numbers from 7, 8-ish to 50-ish. That's a range of 42-ish. So if I wanted my bin width to be 5 is a nice number. I'm sorry, if I wanted the number of bins to be like 10, that would give me a bin width of like 4. So equals this, divide by that. So I just kind of play around. You know, maybe I want 8 bins. What would 8 bins look like? That would be more like 5. Google had 7 bins. That was more like 6-ish. So this is just an estimate to figure out the width. So I think I'm going to go for 8 because I like the number 5. That's a sweet number. The smallest number is 7. So I think over here, I'm going to do a couple of different things. I'm going to have the bin maxes and then the frequencies. And I'm going to come back and add a column that's more human readable, and I'll explain why in a sec. This is in other videos I've recorded before that are in your Canvas page for videos. So maybe I'll have the first group stop at 10, and then the next one would be 15, and so on. So that means the first group will have the 7.9 in it. And then I can just fill that down. That gets me up to 40. I need to get up to 49. 50. All right, so usually I decide, you know, what I want the space to be, and I just need a sample of 2 to do that. They're 5 apart. And then you highlight those 2, use the magic fill button and drag down until you're just past whatever the max is. If you're a Google user, then just go here and type equals frequency. And then highlight your data, comma, scroll back up, and highlight your bin maxes. Close parentheses, hit enter. So if you are an Excel user, depending on the version of Excel, it's a little more complicated. In Excel, after you pick your bin maxes here, you would highlight a cell for each bin max +1, then let go of the mouse. I'm not holding the mouse. Just type equals frequency. And so you have that extra first step. Grab the data like I did before, comma, scroll up, grab the bins like I did before, close parentheses. Extra last step for Excel users is you have to go Control Shift and then tap enter. So you hold down Control and Shift, hit enter, and it'll fill that out. So if your version of Excel doesn't work the easy way, then you have to try that the hard way to get the frequencies. Next thing as I do is I make a quick bar chart or column chart of this. So column, so that's what it looks like. Now, there's several problems with this graph. One is the titles suck. So we need to write good titles here, here, and here, and that depends on your data. Next thing is 15. What does that mean? That 15 countries had a birth rate of 15 and 20 countries had a birth rate of 6? Answer is no. These are actually ranges of numbers. So this one is 5 to 10. This one is 11 to 15, and so on. So I need to put human readable bins in here so that it makes sense to other people. So I'm going to say I like the look of this chart. I don't want to do it again. If you don't like the look of it, then just redo the bins here. So maybe you decide, nah, I think I'm going to go with 6, right? So maybe you go from 10 to 16 and your width is 6. And then you can then recalculate those numbers and see if you like this graph better. So I'm going to undo that, put it back the way it was. I like this one just fine. So I need to sneak in here, adding a column to the left. And this is where I put the human readable bins. And I'm going to give them the crappy title of human readable. A better title would be birth rates. And then this one right here is from 5.1 up to 10. And the next one would be from 10.1 up to 15. And you might want to say, well, isn't it from 11 to 15? And the answer is no. I got to take into consideration that my data has 1 decimal point. The book does it a little bit different. So this is to ensure that I don't accidentally have a specific number that falls on a boundary and I'm not sure which place it goes into. So what the book does is it just says in your human readable bins, just make them go 1 extra decimal place. That way you never have a boundary for a group that is a data value. So you're always sure where things go. So they would have called this like 10.0, just an extra number in there. I like to pick nice numbers and whole numbers whenever possible, and then just match the decimal on the beginning number with how many decimals are in the data. So the next one here would be 15.1 up to 20, and then 20.1 up to 25, and so on. So fill in all of those. And then when you make your chart, humans will be able to understand better what's in each category. Up to 30, 30.1 up to 35, 35.1 up to 40, 40.1 up to 45, and finally 45.1 up to 50. And notice that we have this extra number down here. The computer frequency function automatically looks after what you said the last number was and checks to see if there was anything you missed in case you got the max wrong, which is a good feature. Once the human readable bins are in there, then you're ready to actually make your real frequency table. So insert a bar chart and then put better titles in here. So I usually think about what would my mom appreciate as a title. So I would say birth rates, various countries. And then I think I'm going to also add a subtitle that says these are births per 1,000 people per year. And then human readable was a shitty name down there. That was for me to tell you what the heck I was doing. These are the actual birth rates. And frequency is a technical term that most people wouldn't appreciate. So what am I counting here? Well, I'm counting how many countries had a birth rate from 10.1 to 15. So here I would say a better title would be number of countries. So you want to make this as human readable as possible. And it says I didn't spell that right. You auto spell it for me. Thank you, Google. All right, so I think this is a much better looking one. I have hopefully understandable titles in each place. And my goal is that this is understandable by somebody who knows way less math than me. And you know more math than most people you know, given the position you're at in your life with this class. So just think about somebody who knows less math than you. And if they looked at this chart, would they understand what you were trying to portray here? All right, so that's the frequency table. Stick that down here. The relative frequency table we can just tack on here. So I'm just going to make a abbreviation, relative frequency. And relative frequency is always the frequency divided by the total. And I believe I picked 51 numbers here. I better double check that with a count. Count numbers. Ooh, whoa, how did I screw that up? Again, there we go. Yeah, 51. So here again, I take the frequency, divide by 51. I'm going to make it a pretty percent. And then I can just fill that down. It would calculate everything else. To make sure you got the relative frequencies right, down below, put a sum. A total equals sum is the function for totaling things, and then highlight all those relative frequencies, and you better ensure that you have 100% of the data accounted for. So I do. So it came out right. The sum of the frequencies, if you did that, that should come up to however many numbers are in your sample. So if I do a sum here, the numbers above, it better come out to 51. Yep, check. So that's the sum of the frequencies. Sum of the relative frequencies as a percent is 100. And just remember, if I change 100% to a regular number, format number, it is the number 1, which means a whole group. So one whole is 100%. Cool. All right, so now one problem I have is I want to graph these numbers here with these human readable numbers over here. I'm going to relabel that human readable to birth rates. So the way to select two things that are disconnected is use your mouse to make the first selection, let go of the mouse, and then hold control and make your next selection. It's a little tricky on a touchpad. I think I got it. Then say, give me a chart. And the difference is this should look almost exactly the same as the other one, except the side, the vertical scale is now in percents instead of whole numbers. And then give it a better title. This is good down here. Relative frequency should be something better, like percent of countries. I'm gonna fix that one right now. Percent of countries. And I spelled it right that time. All right, and definitely give it a better title. If you submit a chart and it has a shitty title like this, then you'll definitely lose some points on that. So please, please, please think about nice titles. The act of expediency, I'm gonna skip that for the moment. I'm gonna stick this next to that one down here. I'm gonna zoom out to do that. All right, no chat questions at the moment. So if you have a question as I'm going through this, feel free to pipe into the chat or just turn your mic on and give me a shout. All right, so next thing I want to do is I want to add a box plot to display with this, and I want the scale of the histogram to match the scale of the box plot. Some box plot generators give you a downloadable image, most do not, so you have to do a screenshot of it, and that's why I sent out that video the other day. So I'm going to highlight this data, copy it, and go over to stat key. I'm going to delete stat keys data and paste in mine. All right, so notice mine has no header row at the top, so I'm going to uncheck header row. And I don't have the name of each country on the side, so I don't have a first column of identifiers. So double check that whether you should have these selected or not. And generally I don't. Sometimes I'll have a header title at the top. Click OK, and then click box plot. You cannot copy and paste this, so you can't right click and say copy image, it doesn't work. So what you have to do is a screenshot. In Windows, it's either the snipping tool or the snip and sketch is the new version of the snipping tool. If you're a Mac user, it's Command-Shift-4, I believe. If you're a Chromebook user, I forgot, but if you can't figure it out, message me and I'll help you figure it out. So I want to do a new rectangular sketch here. Snip now. And it's set to rectangular sketch. And then I don't need this top of the box here, but I do need the top of the picture here. So, and I also want the scale at the bottom, otherwise I can't properly line it up. So this is about what you need to highlight. And then you have to save it. You can't copy and paste. So then I hit save, and I give it a name that I can find again. Switch courses here. 243. Let's call this like awesome box plot. Number 6. I think I've made at least 6 of these this week. All right, so I'm done with snip and sketch. I go back to my spreadsheet. Oh my, it's untitled. Let's fix that. Birth rates. Countries. Yours should already come with a good title. And insert the image, and Excel works pretty similar. Upload it. You can do this in Excel 365 on line 2. Documents, work, find wherever you saved it. Awesome box plot, and drop it in there. Now when it first drops in, the size is going to be way off. Where are you? Hello? Oh, whoa, yeah, look at that sucker. So then click on it and then resize it. So I'm just gonna do a quick, and always grab the corners to resize it. If you grab one of the end things, then you just kind of mess it up and it's not readable. So Control Z, undo, use the corners to resize so you don't distort the image, and then guess at a size, and then try and line up with the scale with either one of these. I don't care which one. So either stick it with this one or stick it with that one. So let's see. So since this is 5.1 to 10 and this is 10.1 to 15, I'm going to say 10 is right in the middle here. And then 15 would be right in the middle here. So I'm going to try and line that up. So I'm going to put the 10 right in the middle there. These are off. Like I want that 45 to be way over here. So then resize some more. And I think I'm pretty close there. 10 is kind of in the middle there, almost a tiny bit smaller. So just kind of mess around till you get it nice. All right, so that lines up nice. So then just move it either above or below. And then again, make sure that these vertical lines here line up with wherever you were aiming on your histogram. So now I have a histogram lined up with a box plot. And what I should see is if there's a tall stack somewhere, it should relatively line up with a narrow part of the box plot. If there are multiple short stacks, that should line up with a wider part. So notice the shorter stacks are over here and the widest part is over there. So one question is, well, why does it do that? So let me explain that. I need a screenshot of you to scribble on. Let's see, Charlotte uses a Chromebook, so help would be amazing. Googled it and found it. So what do you do on a Chromebook, Charlotte? For a screenshot. Control Shift Switch. Okay. Control Shift Switch on a Chromebook. And I can't demo that because I don't have a Chromebook. Keep thinking about getting one, but I haven't. All right, so I want to draw on this to kind of explain why things work the way they do, and we compare a histogram to a box plot. And let's stick that in the current page. And let's see if I can get, please go away, assistant. Thank you. I gotta figure out how to turn that off. All right, let's get, whoa, my pen is freaking out. Please behave for me today. So what is a box plot? So a box plot gives us a what we call the 5-number summary. So the number that makes this mark right here, uh-oh, my pen is just like not behaving. Why are you glitching? Huh. What? Okay, so I'm having technical difficulties. My pen is not drawing where I'm pointing. Holy crap, what is going on with you? What? All right, sorry. So I'm just gonna have to point and talk with my touchpad. I can try and draw with the touchpad. This number right here is Q1. And this right here is my median. And excuse my writing, I'm trying to draw with my touchpad on my laptop. That's Q3. Oh boy, 3 is gonna be interesting. This one right here is the max. Eek. Oh boy, you gotta get a kick out of life sometimes. And this one over here, that end mark right there is the min. And remember, a quartile is also a percentile. So the first quartile is the 25th percentile, which means it's the point, the number in the list that marks where 25% of the numbers are at or below that point. So what that means is from this mark over to this mark right here is 25% of the data. So 25, oh my, percent. Oh, this is worse than drawing with a mouse. I don't know if I've ever tried this before. And then the span from here to here, that's another 25% of the data. From here to here, another 25% of the data. And then from here to here is another 25%. So what it shows me is the beginning 25%, they're all tightly packed together between a couple of numbers. And if I go back to stat key will tell me more about that. So stat key says, come on, mouse, that the min is 7.9, quartile 1 is 12.5. So that means the first quarter, the first 25% of data is between 7.9 and 12.5. So that's a narrow range for that group of 25% of the numbers. So let's see, what's a quarter of 51? That would be like 12-ish, maybe 13. So 13 of the numbers are crammed in between 7.9 and 12.5. On the other hand, there's a much wider distance from 34 to 49.7, and 13 numbers are crammed in there, but they have more elbow room, okay? So here's more elbow room. So this would be like living in Portland, you're packed together with a bunch of people. This is like living in Eastern Oregon, you're kind of spread out, you got lots of elbow room. And that corresponds again to the histogram. So here I have very few numbers in each of these categories, so they're spread out. But over here, I have a ton of numbers in there. So this group of numbers in this column is 15. A quarter of 51 is around 13. So this contains, some of these numbers are in the first quartile and some of the numbers in this column are in the second quartile. Can you make a histogram that always matches with a box plot? No, I don't think so. That's kind of tricky because they're measuring two different things. These are fixed width, these are fixed percent. So those are two different ways of measuring things. If I were to sort this data just to check, let's do that. So to sort a group of numbers like that, you have to go to data sort range. Excel works the same way. I do have a header row. I would like to sort by the birth rate from smallest to largest. All right, so let's see, what did they say? Stack, he said 12.5 marked the first quarter. 12.5 is the first quartile. So that would be one of these numbers right here. I'm going to guess it's that one. And if I highlight those right there, how many numbers did I highlight? I highlighted 13 numbers. So the United States is the 12.5 that marks the first quartile. So I'm just going to label this number Q1. And the numbers at or below that point, this whole group of numbers, let's make those yellow. This is a quarter of my data, right? Because a quarter of 51 is about 13. The quartile is a position that marks the end of the first quarter. So a quarter is different than a quartile. Quartile is a position, a quarter is a group of stuff. And then the next quarter of numbers goes up to the median, which is 20.9, so we can mark that off. 20.9 right here. So this group of numbers right here marks the second quarter, the second fourth of the group of numbers. So let's colorize those just for fun. Oops, shit, wrong button. Sorry, excuse me. Delete. Color, there we go. Let's make you guys bluish. And so this one right here is the median. And the median, remember, is the second quartile. So we could call it Q2. It's also the 50th percentile. So I could say it is P50. All right, wow, that was fun and exciting. Okay, so I think I did everything that you're going to do on a different set of numbers for the application. Make sure you have good titles. Like this is a good title here, but that's a crappy title here. Before I turn it in, I better fix that. And then what are you gonna turn in? If you're a Google user, you're just gonna get the shareable link. And so I would get shareable link, copy it, and then I would go over to application 2 and I would submit it because everything should be contained in that file. So just switch to the student view. And come down here and say something like, here is my Google Sheet. And I'm going to highlight the phrase Google Sheet and link it with the shareable link. If you're an Excel user If you're using Office 365, you can do the same thing, and you could say, here's my Excel sheet, and get the shareable link from Excel 365. If you're an Excel desktop user, then you would attach your file, your Excel file for me, and always put a little note, okay? So you'll do one or the other. Give me the shareable link or upload your file with the attach button here. And then hit submit. And in it goes. And once I've graded it, which hopefully next week will go a little smoother than this week, your grade, you'd have a score here. Once you have something other than a 0 there, at the end of this page here is where I'll write up my feedback. And right now the feedback says this assessment contains items that are not automatically graded. Your grade may be inaccurate until your instructor grades these items. So if you look here and you don't have a grade and that's the message still, it means I haven't gotten to yours yet. Once I get to yours, you will have a grade and I will write feedback about it. And the feedback will be either nice job, I love the titles on your histograms, or if you had problems, I will write about what the problems were. And you can try and fix it and message me fixes within a week. All right, let's see. Other questions we got online. Number 13 from the practice problems using the locator method. Okay, so the locator method was mentioned in the book in chapter 2, measures of location. Scroll down somewhere toward past the middle. Okay, a formula for finding the kth percentile. So this is the locator method. I is the position of the number in the list. So for example, in the data I have right here, done. The United States here is the 13th number in the list. Now you might say, no, it's the 14th. See the 14 over there? But again, there's a list of titles at the top, so those row numbers are 1 off from the actual number. So I for the United States would be its position in the list when they're in order. It's the 13th number. France is the 12th number. The I for China would be 11. All right, let's see. Another question popped up. Computers on 13, forbid, that didn't make sense. Okay, so let's walk through. Man, I got to get my whiteboard to work. Let me try something again on that. And we'll look at number 13. What is wrong with my tablet? Why were you freaking out on me? Battery, no, should be okay. Mapping. Just use the bottom screen. That should be okay. Pen. Those settings look all right. All right, let me give it another try. Why were you freaking out? It's still freaking out. It's locating 2 different spots. Damn. Okay, so I will find a way to communicate without writing stuff down. Homework. Come here, mouse. Home. Practice. I want number 3. Oh shit, that's week 1. Sorry. Week 2 practice. There we go. Continue. That's better. All right, number 13. All right, so here we're comparing the locator method with the spreadsheet method. Oh, good. So I'm going to copy this set of numbers into a spreadsheet and do both methods there. And there's 117 numbers. I want to find P38. So I need a new spreadsheet. Actually, somewhere I already have one. This. Where is week 2 practice? There it is. Chart for number 13. Oh, I already have a number 13. Okay, let's do 13 again. and then paste the data in. Okay, so I want to find P38. In order to find P38, I need to find its location. And let me blow this up a little bit. Zoom, there we go. And the location is called I. It's the index of the number in the list. Index is a lookup thing. So I means look it up. To find the index, what you do is you always take the percentile value, 38, as a percent. So that would be as a decimal, 0.38. And you always multiply by the number of items in the list plus 1. So this has 117, 117 numbers, add 1 to that. And so this tells me 44.8. So there's a 44th number and there's a 45th number, but there isn't a fractional position. So this tells me right here to go find the 44th number and the 45th number and average them. So actually, let me make that more clear. This would be the 44th. This is going to be the 45th. And so I just look in the list for that. So there's 1, 2, 3, 4, 5, 6, 7, 8, 9 in a row. So I have 9 here, and then 18 in this, come on, 18 at the end of that row, 27 at the end of that row. What's next? 36 at the end of that row, plus 9 is 45. Okay, so the 45th number is right here, and the 44th number is right there. So I'm just going to go grab that number. There's the 44th number. And I'm going to grab the 45th number. Is that this one? Yep. And then I'm going to average the two of them to get P38. So equals this number plus that number. And you could do this on a regular calculator too. Divide by 2. And right in between there is, for my set of numbers, 3,141. Now that's using the by hand method. That's just for educational purposes, just to try to get an idea about what the heck it means to be a percentile. So what does it mean to be a percentile? Well, right in between, where was it? These two numbers marks the position in the list where 38% of the numbers are at or before that. So if we double check that, if you take the 44.84th position, which is kind of a weird position, but it's in between.
Can you go back? Can you say again how you got that 44.84? Sorry, the for it.
Yeah, give me one sec. I just want to double check that.
Okay.
If I take that and I divide by the number of items in the list, 117, then I should get approximately 38% of the data before that. Okay, so how did I get that right there? The formula is in the book. So formula for finding the kth percentile, you take your k, so my k was 38, and you divide by 100 and then multiply by the sample size plus 1. And that gives you the I, which is the position in the list, if the numbers are in order, and those numbers were in order. So to do that here, let's delete that. I said, all right, take 38 as a 38%, which is as a decimal, which would be 0.38. And then I multiply by the sample size plus 1. So I could just think in my head that's 118, or you could type 117, the sample size plus 1. And that's how I got the position. So this says go to that position right there, the 44.84th position, which means you have to look at the 44th and the 45th number, and we always average them. Now the way the computer does it is a little bit different. So all this work right here was for the locator method. And in reality, we never do that, but that was just for educational purposes. The spreadsheet technique to find P38 would be to just use the percentile function. And Google offers multiple, as does Excel. So I usually choose percentile, which is the same as percentile inclusive. In Excel, you just have percentile inclusive or percentile exclusive. So I'm going to go for percentile inclusive, and then you highlight your numbers. and tell it which percentile you want, and it wants the decimal version, so I would type 0.38, and it says 3,159.92 is the position of the list in the list where 38% of the data is at or below. Notice it's near the number I identified over here, but it's slightly different. Okay. So that's the spreadsheet version of that. And Excel does the same thing. StatKey doesn't do percentiles, but most spreadsheets do. So then this problem right here says, okay, what's the position in the list? And it says don't round yet. So the position I found was 48.84. And then what's the number you get when you look up that number in the list? And when I looked up that number in the list, it was between these two numbers right here. And when I averaged those two numbers, I forgot what I got now, 3,141 was in between those two numbers. And yours will be different than mine because you won't have the same set of numbers. You will get 117 of them, and you will be finding P38, so your locator is the same, but the actual value will be different. And then the spreadsheet told me it was a little bit different. It was 3,159 point something. And this one says integer or a decimal. So I'm going to go with the decimal version, 0.92. And hopefully I did all that right, and I'll get a little green flashing thing. Oh shit, what did I mess up? I screwed something up. Cool. I love making mistakes. It's a good thing. I learned something. So did I count wrong over here? Oh shit, I started counting in the wrong row. Damn. All right. All right, so shit happened. I highlighted the wrong set of data. Okay, so I should have been looking between 311 and 312, and I can just pretty much look and say, oh, that would be 311.5. So again, I looked in the wrong place in the list. It should be 3011 and 3012, which gives me 311.5. And so that means I must have highlighted the wrong set of data here. Yeah, I started in the third row instead of the first row. That'll definitely screw stuff up. All right, so you should check your work. The homework forces you to check it by telling you if you're right or wrong. Okay, 312.96, that's more like it. All right, so back here, 11.5, that's the one. And this one was what, 12 point something. 96. All right, so location versus value is what this is getting at. Numbers have a position when they're in order, and that position has a number to go with it. And that's what percentiles tell us about. All right, let's see. Bailey also asked about number 12. Sure. High and low fence thing. Yes. Okay. Problem number 12. So you're given a set of numbers here. In this case, you're asked to use, again, the locator method, which I was just doing, and then to find the lower fence and the upper fence here. There's a video on this too in the video collection. The min is easy to grab here. That's 2. The max is 98. The median is in the middle. There are 2, 4, 6, 8, 10, 12, 14 numbers. So the middle number would be between the 7th and the 8th number. 36. So for me, 7.5.
54.
And then somebody has their mic on, if you wouldn't mind turning it off for a moment. So that's my middle number. And then to use the locator method to find the quartile, again, the locator method, let's bring up a new number 12. So I want to find Q1, and remember Q1 is equal to the 25th percentile. So to get the I, the location of the 25th percentile, you would go 0.25 times the sample size plus 1. So my sample size was 14. So this says the location is the 3.75th position. So that means look in between the third value in your list and the fourth value in the list, and then average those two numbers. So that's the by hand method. And it will differ from the spreadsheet. So if you copy these numbers into a spreadsheet and ask for the 5-number summary, you'll likely get a different quartile 1 and quartile 3, which will throw off everything else. So let's see, 1, 2, 3, 4. So between 10 and 18 is 14. And then going the other way, it works symmetrically backwards. So if you count backwards, 1, 2, 3, 4, it'll be between 84 and 90, which is 87. So that would be my 5-number summary. The IQR is the distance between the first quarter and the first quartile and the third quartile. So 87 minus 14 would be my IQR. So that's going to be 73. And then the rule says to then multiply that number by 1.5. So let me put this in my spreadsheet so I can keep track of it. So I have a min of, let's see, I need to split my screen here for a sec. My mouse is being sketchy. All right, so my min is 2. Q1 is 14. The median is 57.5. Q3, 87. All right, I need a calculator to get this right. This is my calculator, and the max is 98. So the IQR, put that over here, is then the distance between Q3 and Q1. So we go equals, take Q3 minus Q1, and you can totally do this on a handheld calculator or on a piece of paper. And then to get the lower number, we want to take Q1 and then subtract 1.5 times the IQR. So to make that calculation, I take Q1 and subtract 1.5 times the IQR. And a common mistake here is people forget to multiply by 1.5. And it tells you to do so right here. This is also described in section 2.3, I believe. So I get negative 95, which is way beyond my data set, which means there's no numbers on the low end that are unusually low. And then the upper fence would be Q3 plus that expanded IQR. So 1.5 times the IQR. So in a spreadsheet, I like to have labels and calculations. So Q3 plus 1.5 times your IQR. So my upper fence is 195, which is way beyond. And so the reason here is we have a very wide box for the box plot. And then we have narrow whiskers on this box plot. So this particular set of data has a very short whisker on each side and a wide box in the middle. Notice the box is 73 units wide, but the first whisker is only 12 units wide, and the second whisker is, 11 units wide. Okay. So that means there's no outliers here. So this would be negative 95.5 and 196.5. And again, your numbers will be a little bit different. So that's a technique for finding outliers. The locator method that I use to find Q1 and Q3 is used for educational purposes only to help people wrap their mind about what the heck a percentile is. Generally, I'll use a spreadsheet to do all this and have it find Q1 by looking at my data. And it uses a different technique than the locator method. It's a wee bit more complicated. And I keep meaning to post about how a spreadsheet does that, just for fun. All right, let's see. Do we have anything else going on in the chat? No more messages in the chat. Any messages from the homework system? We do. I have a question maybe about number 10. That was about the locator method, which I just covered here. Okay, so that should be good. All right, anybody else have any questions? It is 11 o'clock. Good time to stop. No questions in the chat. All right, so before I sign off here, just a reminder about this week. Hopefully you read the relevant sections in the textbook. This week we were covering sections 2.1 through 2.4, and there were also questions from section 1.3. Because in chapter 2, we built histograms, and histograms are just bar charts based on frequency tables. So we're reviewing some of last week's materials this week. You've got the practice problems. Let's see. Hey, Kay, sorry I missed you signing in there. Good to see you. I recorded this session. I will post that recording in my YouTube playlist within the hour. So this week you've got your, after you read the book and watch some videos, and there are multiple sets of videos in here to take a look at, do the practice problems, your critical thinking. I made my first post. I'm gonna make an amendment to my post because some of you gave me some good ideas after reading yours. So do your critical thinking, read the posts of others. Once you post, you'll be able to see what everyone else did, and then make an amendment, either an addition or correction to your post. You don't need to reply to others this week. Next week you will for a grade. And then make sure you turn in your application for this week, which I demonstrated earlier. If you have any questions between now and then, just send me a message through the homework or through the inbox here, and I will get back to you as quick as I can. So take care, do good math, stay sane. It was wonderful to be with you all today. Bye-bye.